Hello and welcome to another video on our YouTube channel. In this video we are going to talk about the solutions to exercise 2 of assignment 7 in our course Competition Policy and Strategy. This exercise is about horizontal mergers in a differentiated Bertrand competition model. Alright, a lot of words, but it will become clearer in a moment. So, the situation we want to analyze in this exercise is, as we are quite familiar with by now, an oligopolistic market, and in this oligopolistic market we assume that there is Bertrand competition, meaning firms are competing by choosing prices as their strategic variable. In this oligopolistic Bertrand market, we then know that there is 2 profit maximizing producers of fruit juices, so there's two goods and 1 firm per good. We know that the producer A, Apple Dream, produces apple juice, and producer B, for Banana Pride, is a supplier of banana juice. We furthermore know, and now this is the very crucial part in this exercise, we know that the juices are perceived by the consumers as differentiated goods, right? So this is the first time that we are looking at differentiated goods in one of these competition models. And we will see in the following that this makes quite the difference when it comes to equilibrium results. Alright, now because we have differentiated goods, we of course need to have demand functions for each of these goods individually, right? So the demand functions are given on the slide. There is a demand function QA, so the demanded quantity of good A, which is a function of both the prices of good A and the price of good B, so PA and PB. And this demand function then reads 12 minus 2 times PA plus 0.4 times PB. Alright. Then lastly, we know that both firms have identical constant marginal costs of C equal 2. There is no fixed costs. So, alright, let's take a step back for a second and just think about what we see right here and on this slide already. So, as I said earlier, we are familiar with the Bertrand competition model, right? We talked about the Bertrand competition model for the last few weeks several times. However, until now, we always assumed that there is a homogeneous good in the market, and this homogeneous, this good in the market being a homogeneous good, then had some very crucial implications. First and foremost, each firm competing in this market could just undercut their competitor marginally and sell their good marginally cheaper. And because the good is homogeneous between all producers, well, the consumers really don't care from what firm they buy, so they buy from the firm that offers the cheapest price, no matter by how little the margin is in prices. Now, all of this is quite different when it comes to differentiated goods, of course, because now consumers will not, other way around. Now the demand a firm is facing will not drop to 0 as soon as their price is marginally larger than the price of their competitor. But instead there's some substitution going on between these goods of these 2 firms that is not a perfect substitution. And we can see this when we look at the demand functions, right? We can see that the demand for good A is increasing in the price of good B. So in case firm B decides to actually decrease their price, well then the good for the demand for good A decreases as we are used to see it, but it doesn't decrease to 0, right? But instead there is some dampened effect of the price of one good onto the demand for the other good. Alright, now with these general remarks on this competition model out of the way, let's start with the tasks themselves. In this first step, in task A, we are asked to determine the equilibrium price for the two suppliers of fruit Pi star, so equilibrium prices for both goods, now with an index I, which may take values A and B respectively, depending on which good they are representing, of course. Now, how do we find the equilibrium price for the two suppliers for fruits? Well, we actually already have all the tools we need to solve this problem, even though this is a new competition model that we have not seen so far. Because what we need to find an equilibrium is best responses, right? We know that in Nash equilibrium, all players, or in this case all firms, will choose their strategic variable, in this case their price, so that it is profit maximizing, given any strategic choice of the competitor. And we did this, of course, when we were analyzing Bertrand competitions with homogeneous goods. We did this already, of course, when we were analyzing Kono competition with homogeneous goods. And we are doing the exact same now in a price competition with differentiated goods. So the first thing that we need in order to find the market equilibrium, of course, is what is the profit functions of the firm, or what are the profit functions of each individual firm, so that we can then find the profit maximum. Because that is, well, right, in equilibrium both firms will have their profit maximizing strategies. Okay, so now the profit function is defined as is written here in the slides. And what we are basically reading here is, of course, this is Qi, and so in the first brackets we see Qi, so the quantity of firm I, and we simply substituted the demand function, right? So we plugged in the demand function for Qi and yeah, into this profit function. So as we saw in the previous weeks already, what we then result with is quantity I multiplied with the profit margin of the individual firm. This is, of course, true for both firms in this scenario, simply by the fact that both firms are symmetric in the sense that they are facing the same symmetric demand function. You will notice that this demand function actually is the exact same for both firms, the only difference being that the indices are interchanged, of course. All right, now given this profit function for both firms, we then find the profit maximum. And because we are in a Bertrand competition, well, by assumption, the profit maximizing strategic variable of choice is prices, Bertrand competition. So we find the profit maximizing price of the respective firm, or expressed in more technical terms, we need to calculate the first order condition for this maximum by calculating the partial derivative of profit function of firm A, so pi A, with respect to the price of firm A, so PA. If we do so, well, then we get this first order condition for firm A, and in the next line you can read the first order condition of firm B. Of course, again, they are symmetric. Simply interchanging the indices will provide both of them. And then finally, similar to what we know from solving Kono competition models, we can then find the market equilibrium prices for both firms by solving this equation system, where of course we have two equations and two unknowns, so we can simply solve this linear equation system and find out that the equilibrium price in this scenario is PA star, of course, equal to PB star, equal to 4.44. So that is the equilibrium price for the two suppliers of fruits. Now in the next step, we are asked to assume that both companies merge and continue to offer both variations of the good after the merger. We are asked to determine the price that the newly created company called A and B will set. Yeah. Excuse the mistake on the slide. So, and we will call this price P with an index A and B. All right. So just following the notation of the previous slide, of course. All right. So now, if we want to find the profit maximizing strategy for a monopolist, and so for the merged firm, which thereafter is simply a too differentiated good monopolist, of course. If you want to find the profit maximizing prices, well, we have to start by stating the profit function of this monopolist. And yeah, the profit function of this monopolist, so the profit function of this now merged firm that is now by assumption continues to offer both variations of the good after the merger, well, it's simply the sum of both of the individual profit function of the firm pre-merger. All right, and that's exactly what we see down here. So the profit function of the now combined firm, or of the now monopolist A and B, as a function of the prices for good A and for good B, then becomes simply the sum of the profit the firm makes by selling good A plus the profits the firm makes by selling good B. And you will recognize these two parts of the profit function from task A. Now, how do we find the profit maximum for this monopolist, who again, just as a reminder, this monopolist can choose both goods prices, PA and PB, in order to maximize their profits? Well, how do we find the maximum of this function, which depends on PA and PB? Well, we start by stating the first order conditions of a maximum of this profit function, right? Or in a more economic sense, well, we find the profit maximizing strategies for the parameters of choice, the prices for each of the goods. And yeah, these two first order conditions then, of course, are calculated as the partial derivatives of this combined firm after merger. So the partial derivative of the profits of A and B with respect to PA in the first order condition, and then with respect to price B in the second first order condition. Right, so then calculating the derivatives of this profit function with respect to to both of these parameters yields the two first order conditions written on the slide, and then again, well, the following step is of course the exact same as it was in the previous situation. We have now a linear equation system where we have two equations and two parameters, PA and PB, so we can simply solve this equation system by substituting, or whatever way you prefer to solve this kind of problem. Right, if we do so, well, then we can find out that for this problem of a joint profit maximization, or in other words, in this situation where there is one single firm selling both goods and maximizing their profits over selling both goods, we see that the new equilibrium prices of this adjusted situation now are 4.75. So, interestingly, we see a price increase, right? Going from the situation under task A, where we had two competitors, towards the situation we are now observing in task B, where we have one monopolist or one merged firm that results from the merger of these two competitors under task A. We now see an increase in prices. All right. Determine the prices that the newly created company A and B will set. So we're done with this task. Let's move on to task C. In this task, we are now asked, first off, this task is optional, which of course means that it's first not asked in the Ilias tests that we are, or the Ilias assignment that you are able to hand in online. Furthermore, I will go over the solutions in a little more brevity, simply because we have other tasks to cover in this week. All right. So, in this task C, in this optional task C, we are asked to determine the upward pricing pressure UPP for firm A that results from the merger of the two firms. From the merger of the two firms A and B. For this, we are first asked to determine the function QB, so the quantity of good B as a function of the price of good B and the quantity of good A. Then we are asked to calculate the implicit text TA, the gross upward pricing pressure index, or GUPI, GUPPI, that firm A and B would introduce to internalize the negative external effect of the merger. All right. So let's first, at this point, spend a minute to talk about this negative external effect of the merger. Well, this of course refers to the interesting result that we saw in these first two exercises, where we saw that after the merger, simply because this negative spillover effect from increasing one goods price, decreasing one goods price to the, on this slide you can see it better, this spillover effect that results from the decrease of one goods price, lowering the demand for the other goods price, this negative externality that is then internalized through the merger, right? Because in the profit function of the merged firm, you now have both of these terms included. So this spillover effect, or this externality effect, is then included. Well, this is of course what we want to analyze in this now third and final task C of this exercise. So let's have a look at this. First, let's talk about net upward pricing pressure, or net UPP. So, in previous weeks, we relied on concentration-based approaches like the HHI or the concentration ratio in order to evaluate the effects of a merger on competition. This, however, as we have discussed in the solutions in previous weeks when we were talking about these methods, this has some issues when it comes to the application to market with, for example, differentiated goods. And the UPP is then one alternative measure that can help us making an assessment of the effects of the merger on competition. All right, so the idea is that we want to test whether a merger of two firms, or in this case, or in general, whether a merger of firms generates a so-called upwards pricing pressure. That means in this we are going to consider two opposing effects. The first one is that there will be a price increase through the elimination of competition, right? Because we have this gain in market concentration and market power thereby. And then the second effect is the price decrease through reduction of marginal costs, or what we will refer to as efficiency gains. So the idea is, well, under the first point, there is less competition, which we would expect to yield lower allocative efficiency. That's what we saw when we were comparing monopoly, oligopoly, and perfect competition, right? And under second, we now in addition, we want to consider that through a merger, there might be efficiency effects. There might be, the merger might affect the costs of the then resulting firm. Ideally, of course, through some version of economies of scale, economies of scope, or maybe maybe the adoption of a better technology. So through one or several of these channels, we could expect that a merger might reduce the costs, or that we, in other words, might see efficiency gains through the merger. All right, and then what we now, of course, want to do is compare these two opposing effects. And in case the first effect is stronger, so to speak, the welfare negatively impacting merger, well, in case this is the stronger effect, then the merger results in a net upward pricing pressure. And in the following, we are going to assess this. So the net upward pricing pressure in the case at hand. We were first, this is just a repetition of the demand functions, and we can find this function we were asked for, this Q quantity B as a function of price B and quantity A function. We can find this by simply substituting PA in this equation. For one way is to substitute PA in this equation with the equation under 1. Of course, first solve for PA. All right, so we solve equation 1 for PA and then plug in PA into equation 2. And this will yield the equation that is written down on the slide right here. So we now have what we were asked for after rearranging, namely a function that gives us the quantity of some good B as a function of the price of the same good B and the quantity of the other good, A in this case. All right. That's the first step towards calculating the implicit text TA. So let's continue down this path and calculate this implicit text. So the next part we need in order to calculate the implicit text and then calculate the gross upward pricing pressure index is the diversion ratio of A and B. So basically what we need to know is the change in quantity of demanded quantity of good B with respect to changes in the quantity of the other good, right? So the interchanging relationship between these two sizes or parameters in the model, right? So we need to calculate the diversion ratio, which we will abbreviate with this notation d a comma b as index, which is calculated as the derivative of qb with respect to qa. And in this case, if we have a look at the function we just stated, qb, so the derivative of qb with respect to qa, well, that of course is simply the parameter standing in front of the qa, so minus 0.2, right? So that's our diversion ratio. Yeah. So what we then know is that we know the change in profits of good B for an increase in the quantity sold for good B in by one unit, right? By the logic of this derivative. So using this diversion ratio, we can then state the gross upward pricing pressure, so this implicit text TA, because we know that this implicit text results from the product of the diversion ratio DAB and what's basically the price cost margin pre-merger, so the price of good B pre-merger minus the marginal costs of producing this product, right? And by simply plugging in the values we have already found in this model, we can then find out that this gross upward pricing pressure index in this case at hand takes a value of 0.488. This of course is, in this calculation of course there is one implicit assumption. When you compare this to your own calculations or to the calculations presented in the lecture slides, you will realize that you usually would have to consider some efficiency effect, EC, so some change in marginal costs. Well, in this case at hand, we have not stated that there will be any efficiency effect. Rather, we have assumed that the marginal costs of firm A and B are exactly the same as they were for firm A and for firm B pre-merger, right? So there is no efficiency gains in our model. All right, so without any efficiency gains, so with EC being equal to 0, we know that the merger results in a net upward pricing pressure for firm A, and of course, because of the symmetry of the model, analogously for firm B of this value of 0.488.